Alright, here we go with take 3. I didn't have my headphones on the last one. Too bad. Anyways, we've been working on estimating standard deviation of group data. The formula we've been using is this one down here. And it's based on the shortcut formulas that are found on page 137 in your book. I don't know if I have too many bumps there. One too many bumps. Okay. And we've already had one video, but I'm going to do it again on how to do this. So to find the variance, we do this. To do this, we make a column which is f.xm, which is the frequencies times the midpoints, and we do another one which is f.xm squared. And we're going to sum those. This sum is going to go up here, and this sum is going to go up there. And we're going to square it and blah, 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 blah. Fill that all in. Okay, so first I have to figure out my midpoints. In this case, super easy. Then I have to do my frequencies times my midpoint. So 12 times 30, 360, 4 times 16, 640, 5 times 2, so that's 1,000, 6 times 8 with a 0, and then 56 with a 0. And when I add these up, 360 and 640 is 1,000, 2,000, and 3,040 is the total. Now over here I got to do the same thing, but first I have to square before I multiply by the frequency. So 30, let's just write all the squares up here, it might be helpful. 900, 1600, 2500, 3600, 4900. And now I do 900 times 12. 9 times 12, 108. 0, 0. 16 times 16, 256. 0, 0. 25 times 2, 50. But 3 zeros. 36 times 8, 288. 2 zeros. 49 times 8, 400 minus 8 is 392. 0. What I just did there, 8 times 50 minus 1 is the same as 8 times 49, right? But 8 times 50 is 400. Minus 8 is 392. So that's a way to do it. You can make short work of these because these two add up to 50 grand. There's already a 50 grand, so we have 100. We just have to figure out what this plus that is. 288 plus 12 more would make 30,000. So I'm going to steal 12 from here, and that knocks it down to 44. And then we have 244 plus 300 is 544. So we have 154,400. And that is that, guys. Total. So now you just fill in the blanks, and I'm going to do the square root at the same time because I'm not looking for the variance, but I'm looking for the standard deviation. So we do n, which is the sample size, which is 12 plus 8 is 20, plus another 20 is 40, plus 16 plus 8. 16 plus 8 is 24, so plus 40 is 64. I try to look for things that add up to larger numbers when I add. Okay. Plus I've done 3 drafts of this video, so I pretty much know the sums already. Oh, why did I put that there though? That's wrong. Why? Because what I put in the first one, I put the sum of the frequencies times the midpoint squared, which is this column here. So let me erase that. Where's my eraser? Alright. And what am I going to put there? I'm going to put then is it a plus or a minus? It's a minus 30, 40 squared. And I'm going to put big parentheses around all that because I'm actually dividing everything by 64 times 63, and then I'm taking the square root. So that is what you would do to find the sample standard deviation, which we call S. But that's not the only way you can do it. Alex shows a different way, and in case you hit the Alex explanation, I wanted to explain where that came from. If you remember, for sample standard deviation, we had this as the defining formula. This is on page, what page is it on? 136? I don't know. Let's look. It's on page 136. Okay. And what was it? It was the sum of the differences squared divided by n minus 1. For population standard deviation, it's the sum of the differences squared divided by big N, which is the population. The major difference besides these being Greek letters is that for sample standard deviation, it's n minus 1. So, in the same way that we have a formula up here based upon the shortcut formulas right here, we can also develop a formula that's based on this formula down here. Well, when we do, it looks like this. The major difference being where before we had the sum of the differences squared, now we have the sum of the frequencies times the differences squared. But other than that, it's the same thing. So how do we actually compute this if we want to do it this way? Well, I'll do it for you. We do S equals the square root, and I'm going to do a big square root, is equal to the, it says F1. F1 is the frequency of the first class, which was 12. The midpoint of the first class was 30. And then it says minus x bar. Well, x bar is the sample mean. And to find the sample mean, we would take this. We know the sample mean, x bar, is equal to the sum of the frequencies times the midpoints divided by n. So it's basically that number right there divided by 64. And I don't know what that is. Ends in a 0, so it might be 45. It's certainly not 50, because that would be 3,200. But anyways, so whatever that is, we're just going to leave it as x bar, because I'm not actually going to calculate here. But I would do the frequency of the first class, which is 12, times the midpoint of the first class minus x bar, because I still want to get the difference and square it times the frequency. The second class had a frequency of 16, 40 minus x bar squared. Third class was 20, midpoint 15, whatever x bar is. And of course you'd have to calculate it, but we're not going to here. Next class had 8, 60 minus x bar squared. And then the last class also had 8, midpoint was 70, x bar squared. And you probably want to put a big grouping symbol here on both ends before you hit divide. And then instead of dividing by n times n minus 1 for this one, it's just divide by n minus 1. So that's 63. And when you do this correctly, you'll get the exact same answer as you got above. So it's really up to you which way you want to do it. This way you have to do a lot of calculations, in that you have to subtract before you square. You also have to figure out the mean. This other way that we had, you don't have to know the mean. You just do using the shortcut formula. I think that this way is a little quicker, but again, it's up to you. Whichever way works better for you. Now you have both ways. Choose your own adventure. If you have any more questions, talk to me. Bye.